And just like that, it is time for the Nerd Log again. We're back. We're talking about Pixie, the kind of amazing Kubernetes observability tool
I
that
think it's
is,
more than kind of. It's
yeah,
amazing.
it is definitely like as a woman who's occasionally pretty stressed out with Kubernetes deploys and Kubernetes management, it's the first thing that I've seen that's a Kubernetes tool that's like, oh, this seems easy. This seems like it actually is easy, instead of just like, hey, it's just 32 quick steps involving 7 terms you've never seen before. This actually feels easy. And with us is Brad. Brad, say hi to the people. Tell us what you do for New Relic.
Hello, Internets. I am Brad Schmitt. I'm a solution architect with New Relic. I'm excited to be here today to talk about Pixie. Today is GA day.
GA day.
We are very excited about all kinds of new Pixie stuff that you will see in our UI.
Okay, I love it. I love it. So let's start with what Pixie is and why does New Relic care so much about Pixie?
Pixie is a super cool technology based on extended Berkeley packet filter. So EBPF or BPF, if you're one of the cool kids. It is something that runs at the kernel level in a Kubernetes cluster and is able to see things like HTTP calls between services in a Kubernetes cluster. It can see things like DNS latency and network flow between services. And so it's exciting for us because that gives us the opportunity to deploy observability to a Kubernetes cluster. And on day one, without having to add APM agents to your services, you get metrics like response time, throughput, error rate for any services running across the entire cluster, which is super cool, super valuable for developers to then get in and troubleshoot their code and whatnot.
Yeah, the classic situation, right, is, hey, I can give you great data on how you're performing. I just need to, one, have you go in and install something that's like running constantly. Two, maybe even go in and edit your application code to say, hey, before you start up my agent. And three, also, I do need to kill your performance, right? Like, I do need to take an 80% hit off of that. I will need to quintuple your memories, partition, where it's like, okay, like it gets almost to like Heisenberg uncertainty principle. It's like, I try to observe this thing, I've just completely altered it, right? Whereas eBPF monitoring of Linux containers gives like really powerful data. When I first saw like what you can see with this, and knowing that you just did it with a single command and said, hey, go ahead and just enable this, that's pretty sweet. So, and we care about Pixie because we acquired Pixie, and so Pixie's
right
now. And rather than grab that code base and say it was all for us, we decided to go ahead and release the Pixie agent as part of the CNCF org. Yeah,
exactly. Yeah, we are. I think we're in the process of donating it or doing some sort of release there, and so I believe we're still somewhere in the the red tape of that, for lack of a better term. But yeah, we're excited about that. We obviously want to give back to the open source community and continue to be good stewards there. And so Pixie is open source, but we have built an integration and have brought a lot of the Pixie UI features into the New Relic platform so that any New Relic user can take advantage of all the greatness that Pixie brings to our platform.
And the best part is you can do this right now if you log into your New Relic 1 instance, which is my favorite part.
Yeah. Do we want to kind of talk about how we would go through that install process? Maybe that's a good place to start.
Yeah. If we could start there for our demo, I'd love to see that first, because this is the part, like, I love the data. We're going to look at the data in a minute, but this thing of actually like getting data in is just, it flips me out every time.
Yeah, super simple. So we have a guided install. You select, whatever account that you want to install into. We're installing in Kubernetes, obviously. So
starting out with New Relic, you probably have one account, right? But once you get to the enterprise level, right, you'll often say, hey, you need to control where data is getting reported up to. So we'll say like, hey, we have a whole bunch of accounts. Anyway, why am I in the weeds with this one point? But yeah, you pick your New Relic account, and then I love this part. Okay, go on.
Yeah, that's a good call out. You may have one account, you might have 20 accounts that you have access to. So it just kind of depends on your role. If you're part of a large company, you may have multiple accounts. So just be aware of that when you get into the installer. So this is new. We put this little in-product video in here just to kind of give you an idea of what you're going to get when you install not only New Relic, but also Pixie. And so this is just a quick preview of some of the cool visualizations and data that we can bring to you.
Daniel,
so I am
cover for me for a sec. I'm going to go use the restroom, but let's do this install. I'll be right back, folks.
Okay,
you're
so I am going to. That's the way it goes, Daniel. You're stuck with me as well. So I'm going to install into this cluster, and we've got some options here in the next screen to allow you to kind of customize your install. So part of our solution includes things like the ability to scrape Prometheus endpoints in the cluster and looking at Kubernetes events, cluster-wide events in our UI, and also a log collection. So you might want to look at logs from your containers and applications running in Kubernetes. So we give you the ability to install these different components as part of the install process. And then finally, this is the thing that's new here at the bottom. We have a checkbox that allows you to get instant insights and full body requests and application profiling via Pixie. So this is the additive feature that Pixie brings to our offering, and this is what we're super excited about and what went GA today. So if I click continue, what I'm going to get here is basically a Helm command to do an install into the cluster. There are other options here. So if you want a manifest, you can get one. But most people are using Helm, I would say, at least a lot of the customers that I've spoken to. So we add the New Relic repo, set up a namespace, and then we run the Helm install or Helm upgrade command, depending upon where you're at in your journey. So a couple things to call out here. There are some flags to enable the Pixie component. So you can see here we're setting Pixie enabled to true. There are some API keys here, which we will be sure to delete later. And so this allows us to connect Pixie to New Relic. You click continue, and it sits and listens for data. So this would be where you go to your command line, you run the Helm install, the pods come up, and eventually that data registers itself with New Relic, and you get this beautiful success message, and you drill straight into the Cluster Explorer, and you should see something that looks like this. Now, you might have more nodes in your cluster than I have. So my little demo cluster is just a 2-node cluster running in EKS. But this should be, somewhat similar to what you end up seeing once you're done with the install.
I really love that, this piece. It was sort of new when I started a year and a half ago, which is just saying, hey, we're receiving data right now, and trying to give people a sense of like, did they just even do the setup right, really, really quickly is so nice. So I want to see one of these like, charts where we dive a little further into this eBPF data, because I love it as a place to start. That with a single Helm command, you can see like which processes are consuming resources.
Yeah, so let's kind of walk you through this UI a little bit. So New Relic has an infrastructure daemon set that runs, and it kind of powers this visualization. So that's been around for a while. We've had that. But what Pixie brings is the ability to see those services running in your cluster in context in this UI. So an example of that might be, so this is a node. I can select it. I can see node utilization. That is interesting to certain folks. And then we have the pods running on that node. So I know that I have a service called the catalog service in this cluster. So I can use this search to find that pod, select it, and then it tells me, okay, here, it's identified it, it's highlighted it, it's running on this node. And then I can see metadata about that pod. So is it running? Is it not? What namespace does it live in? And then some container utilization metrics. So CPU and memory. I could drill into container details from here. I could look at the logs for this application from here. So what we're doing is we're creating this experience for either a developer or maybe an SRE, so that they're able to easily get to various areas of Kubernetes, whether it be infrastructure or application, in one place. And then finally, at the bottom, this is where Pixie comes into play. So this was all kind of infrastructure stuff. And now I can see my application, which is running in this container, in this pod, in this cluster. And Pixie's providing me web transaction time, throughput, error rate. And from here, I've got a couple options. I can drill straight into Pixie. So if I click on check metrics in Pixie, we get the slide out. And now I'm looking at live data living in the cluster being collected by Pixie itself. So this is what's new, or one of the things that's new in the Cluster Explorer UI. Super cool stuff. So now I can see, detailed requests, errors, latency metrics. If this service had multiple pods behind it, I'd see a list of those pods. In this case, it's just one. And then scrolling down, I can also see, traffic coming into this service. So this is one thing that was challenging for New Relic to provide as part of our existing integrations for Kubernetes. Is we didn't really have a great way of showing traffic direction and source and destination within the cluster. We gave you state, is it alerted or not? But this is kind of taking things a bit deeper. So now I can see who's calling the catalog service and what the latency of those requests look like. And then, is it generating any errors?
Yeah, this part is wild to me that you can actually you see all the way down to request path. It just, it implies a great deal of depth and they're trying to look at what the possible correlation, with a type of path may be. So I always use these e-commerce examples, right? It's like, hey, is it like the coupon code database, right? That's performing poorly. And, even if you're not looking at your entire DB service, right? You could see, hey, this poor performance is closely correlated with, coupon/request or what have you, right? And that seems really, really nice.
Yeah. So what we're looking at now is a sampling of slow requests for this service. So Pixie is able to identify things that are, maybe in the 99th percentile for that service. And then if you click on, it's kind of tough to see, but there's a little icon here that allows you to expand that specific request. So we're not sampling any data here. We're analyzing all of the requests happening for this service. And now I can see, header information. I can see the response body that's coming back from that request. I can look at response codes and, other values that might be helpful to a developer to troubleshoot any errors that might be happening or latency between services. Without an APM agent, that's the key here, is that Pixie is just running in the kernel and it's able to provide this level of detail using EBPF.
Yeah, so speaking of EBPF, for our viewers that don't know exactly what it is, Nika or Brad, can you kind of explain what EBPF technology is and how Pixie is using that to get all this awesome data?
So, I can give a short version. Maybe Brad, you want to take a crack at it? We're both like, we get to that point like, oh boy, we're not Linux core developers. The short version is right. It's a set of tools supported by Linux that allows you to do a great deal of observation about what's going on on that system without directly impacting its execution, without having to go in and add your own instrumentation calls.
Yeah, it's a lower level way of looking at various things happening on that specific Linux node, and it's been around for a while. It kind of originated in the network space, but now we're starting to see other uses for it. And as Linux kernels evolved, it opened up other opportunities to look at things like HTTP calls and DNS flow and things like that are happening within a very complex Kubernetes world, where you've got a bunch of stuff crammed into, this cluster, and they're all communicating with one another, and that becomes really challenging to kind of pull apart when you have an issue, and that's what we're trying to solve here.
Yeah, and so that hopefully that answers most of your question. If you go and take a look over at ebpf.io, which I'll toss in the chat. They have a pretty good explanation there of what is EBPF and what does it do. It's a Go modules for in large part to be able to speak directly to the kernel. And yeah, initially out for network monitoring, now getting expanded out. So
this is a great resource if you want to know anything and everything about EBPF. So this, I believe this guy worked for Netflix and has built out this site very thoroughly, as you can see. So anything BPF related, this is the place to go. And there's some cool diagrams and things of the areas of the kernel you can access using BPF.
Love it. So, Brad, how would you recommend that somebody get started with trying some of this Pixie? I mean, we already saw the install process, but is there more to it than that as far as getting ready with New Relic? Like, let's say they're a current New Relic user and they're running a cluster someplace. Are there other steps that they should take to get monitoring?
Yeah, if they're a current New Relic user, you're already running the New Relic Kubernetes integrations in our infrastructure daemon set, then it's really a simple Helm upgrade to add Pixie to a cluster that you've already instrumented. So we tried to make it as easy as possible, whether you're brand new to New Relic and have never installed Pixie, or maybe you've been a New Relic customer for a while and you're really interested in testing Pixie out. That guided install should take care of most, if not all, scenarios that you might be in, whether it's fully instrumented with New Relic or not.
I absolutely love it. Yeah, we're going pretty deep here. So, Brad, what else do you want to show us? I mean, this is, like I hope some people are kind of like kids in candy shops and running out to try and report this data themselves. But is there other stuff you wanted to show off about our new GA features?
There's plenty more. So one of the new additions indicated by the new badge here is the live debugging with Pixie. So I kind of drilled into a slide out earlier that was scoped specific to a service running in the cluster. But this tab is available just to kind of start at that cluster level. And so you can see here that I have these constellations of services all communicating with one another. And Pixie's UI.
How deep does this go?
We'll go as deep as we can here. So this is
I'm just excited. By the way, I muted myself for a sec so I can be served spam musubi like deconstructed. Got the little seaweed here, rice, spam and eggs. Wrap
that
them.
Sounds good.
On call, just like to show off that I live in paradise, where people bring me snacks like this.
I had some Kansas City barbecue for lunch, so I'm feeling good right now.
Now you've hurt my feelings. Wow.
So what we are looking at, this is something that's new and exciting for us, is the ability to see these connections between services. So now we can understand that the sock shop front end is communicating with the user service, the orders service, and the catalog, and that gives me a better understanding of how some of these microservices might be communicating with one another, what the overall architecture looks like. Because as a developer, maybe I only manage or touch one or two of these services, and I've got another team that takes care of the others. And so this is really helpful to just understand who's talking to who, and what do the latency, error rate, and throughput metrics look like between those two connections.
Oh my God! Oh, so it's not just skeuomorphic in line weight. There's actually you can see a little detail of kilobytes per second. I love that.
Yep. So this is kind of the visual representation of that. And then below this, we really kind of start to dive into the cluster. So I could go look at a specific node. I could drill into a namespace, which I'll do in just a moment. Here's a list of those services that are kind of represented in that service graph up above. I can see things like pod counts. I can see kind of the same metrics that are in that service graph, just in a JSON format down below. So all kinds of cool and useful metrics coming back from Pixie related to the services running in this cluster. So the next step would be,
cool.
Let's say I want to go investigate my sock shop namespace.
Yeah, so now we're at the point where we sort of suspect there's something going on the sock shop. The sock shop sock hop has got a non-op.
You know what? Even better. Let's make something go wrong. So we have the front end for the sock shop app, and there's a bug with this app. So if I select more than one of these filters, nothing's returned. So something's wrong. Maybe we had a bad code update, and now I have to go figure out what happened. So we can start to kind of drill into that from here. I know that my sock shop app lives in this namespace. I was on the catalog page, so I'm going to guess it's the catalog service perhaps that has that issue. So I drill into the catalog service, and look, I can already see that spike in errors that I just generated. So that's how fast Pixie is able to give you feedback as to what's happening within your services as well. One thing I'll point out is you've kind of watched me navigate from the high level cluster down to the namespace, down to the service. And if you've kind of watched the UI, we're using or selecting different scripts here. So Pixie has its own language called pixel scripting. It's very much like Python. It uses pandas like data frames, if you're familiar with Python and pandas, to essentially present data to the UI. And so what we're doing is we're actually just running these scripts, and then Pixie is displaying the output, in a nice UI format. But, I can do the same thing from the command line. So there is a CLI with Pixie that allows me to run these same scripts. So let's say I wanted to build some tooling around Pixie data running in the cluster. I could do a px run px cluster. Maybe I wanted to output that to JSON, pipe it to JQ. And now I've got some nicely formatted JSON data coming straight off of my cluster, hopefully.
So is that going and hitting the Pixie instance on the cluster?
It is, yeah. And that's an important distinction I think we should discuss. So Pixie data lives in the cluster. And it's short-lived, meaning we keep data for about 4 to 24 hours, and it's really meant to be unsampled data for troubleshooting, things that are happening in the cluster right now or recently. And what New Relic brings is the ability to, with our integration, ship a subset of those metrics to New Relic for longer-term storage. Maybe you want to dashboard, what that service performance looks like over the past month. And maybe you want to alert on certain metrics that Pixie is generating. So the combination of Pixie and New Relic gives you kind of the best of both worlds. Pixie is giving you that live look into what's happening right now and the ability to drill in deep into it and troubleshoot. New Relic's giving you the ability to trend that longer term, alert, and do some other things with that data alongside all the other New Relic telemetry that you might have, outside of your Kubernetes cluster world.
Speedy Farf, which is a great username, asks, hey, the Pixie UI is inside of NR1. Is this just an iframe of the on-cluster UI?
That's what I was thinking, but didn't want to say it.
Wow, savage. I don't know. Okay.
It actually is just an iframe as of right now. So,
I'm glad to have it, because anything that cuts down on the number of tabs I have to have open, I love. But yeah, so this is actually going to, rather than hitting the New Relic data backend, this is actually going to hit your cluster to ask for data for this performance.
So does that mean that you don't get charged for it?
That's correct. Yeah. So we even put a little nice note up here that says, hey, you're looking at live data in Pixie in the cluster. We're not charging you for this data. We're not ingesting it. This is data that we're connecting into Pixie and visualizing data, kind of recent data in this way. So super useful to have, especially when you need to get into, say, that catalog pod and figure out, why in the world things have gone wrong. So now I'm down into the pod script. And I can see things like...
Before we dive past this on-cluster data thing, I think it's kind of critical to note, as a big differentiator with Pixie, or sort of why Pixie, is that, EBPF is an existing set of tools of which Pixie has a really cool solution for. But rather than most of the other concepts for it are, hey, it grabs all this data and then it sends it all up to some kind of collector, which tries to analyze it. And one of the really powerful things about Pixie is it emits signals, which you can act on, of course, and generate alerts and all that stuff. But it doesn't have to transmit every single thing that it observes, because some of this stuff is stored on cluster.
Yeah, I think that's an important point as well. Is so, observability can generate a lot of data, right? And, maybe not all of that data is useful or needs to be stored for a long period of time. And so Pixie's storing that short term in the cluster. New Relic's storing, some of the key metrics, response time, throughput, error rate, longer term, so that you can look at those trends over time. So we're kind of satisfying a couple different scenarios or use cases there.
Speedy Far, you missed earlier in the chat when I mentioned that, yes, I am in fact eating Spam Musubi while doing the stream, because the streams are an hour and a half long, and I can't go an hour and a half without eating anything. So therefore, I cannot maintain this energy level on smoothies. Come on now. Let's be realistic. Yeah, I think it's a real important concept because one of the reasons to kind of start thinking about these tools, thinking about sort of more intelligent data gathering, is when you're seeing like teams saying, "Oh yeah, let's just go ahead and monitor just prod," right? And we'll be good with just monitoring prod because we really can't afford to monitor all these test instances. We're paying per alert, we're paying per query, we're paying a bunch of money per gigabyte for storage, and that just puts us in a situation where it's rough, right? Where you're ending up sending problems from dev out to prod because you didn't detect them because you don't have those observability tools.
Yeah, I'm sitting here staring at process data, and I'm thinking, there's a lot of times where vendors will ship, process data, which can be a lot of data, to their platform and charge you for it, and you probably don't need it most of the time. You only need it when things go wrong, and then you have to go figure out, what PID is, running which process. But this is kind of a good example of certain types of data that are useful for troubleshooting, but do you really need 13 months of process data? Maybe not. So it's good to have options as far as to what you store longer term versus what is short-lived and used for specific purposes.
Yep, that totally makes sense. All right, now I've derailed you enough because I went to sing the praises of on cluster data. But yeah, please do go ahead.
Yeah, I mean that's an important subject. So I'm glad you derailed me. I'll get us back on the track though. So we are in the pod and looking at the containers running in the pod. In this case, it's just one, but you might have multiple containers, and those would be listed here. And then within that container, you've got processes running. So now I can see that this app is exposed on port 8080. The PID is 6876. So that's interesting to me. So I can see exactly what's happening in this pod, in this container, in the cluster. And then you get kind of your standard network bytes sent and received, memory information. And I talked about being able to identify inbound traffic to services and to pods. We show that here. Pod metadata. So what node does it run on? What service does it belong to? Or what service sends traffic to it? When did it start? Things like that. And then we get to the flame graph. So this is another feature that Pixie brings to New Relic that's pretty exciting. This is kind of an always-on profiler for your services in Kubernetes. And you read these from the bottom up. So what we're looking at is... Yeah, was there a question? Feel free to stop me.
I was just saying flame graph.
Flame graph, yeah. We are here.
Flame graph.
Okay. So we're looking at the catalog pod, catalog container, the apps exposed on port 8080, and then we kind of get into that, that application space. So as a developer, this would be really helpful for me to see the performance of the different components or pieces of my service that I've written. And notice that when I hover over these, you see the number of samples that are included, in this graph. So I'm looking at a 30-minute window. You can scope this all the way down to, say, the last 5 minutes, and this thing is always sampling what it's seeing happening on that node and presenting it to you in the form of this flame graph. So we can see, which areas of code are taking the most CPU and are the slowest pieces of the code. And you can interact with this. So I'm using my mouse scroll to widen these segments. The wider the segment, the more resources it's consuming. And then you go from this lighter blue kind of application space down into the kernel, which is where all this green stuff is. So if you're super into Linux kernels, these things are probably of interest to you. I am not a kernel programmer or anything like that. So I like the name trampoline. Trampolines are fun, but this doesn't mean a ton to me, but it means something to someone. And I think it's super cool that, we can get to this level of detail.
Yeah, like as a node developer, this is definitely like it's the last half of the stack trace where it's like this raised it to this library, which further raised it to this basic library, which has some problem with bit shifting. It's like, hey, you named a variable wrong, idiot. Like all I needed was those first few lines, but okay.
Yeah.
Not to be too negative self-talk, but that's often my process.
Daniel, you've been quiet. What questions do you have?
I have so many questions, yet no question. I'm kidding. Yeah, so I think this is really cool, and it's pretty easy to get started. I think the demo process was really cool. Um, I don't know why. For some reason, I don't have any questions. Maybe because we did this for like 3 times already,
We,
the same exact
we have been.
example. But
It's
I actually understand what's going on this time, which is like kind of weird. It's a weird kind of unfamiliar territory that I'm in right now.
yeah.
But I understand what's going on.
You know what's funny is I'm kind of in that mode too, where I'm like, now I finally kind of get like, it's so weird to have been working with Kubernetes stuff for a year and only feel like I'm fully understanding like how it's actually used now. I mean, I guess it's sort of what everybody says about Kubernetes, right? It's just not an amateur's tool. It's not something you can pick up and run with. But yeah, I feel like we're getting a better insight now. Now, one thing I'll ask about the service graph: why is if stuff is showing up with no connection, why is it here?
It's a good question. I think potentially there's no HTTP communication between those services. And it is a short period of time, so maybe nothing has happened in this time window that I'm looking at. So there's a few reasons why you might see just kind of standalone things here.
Oh, we got a question from the chat that says, does the flame graph work if I didn't write my app in Go?
Yeah,
it does work. So it works better for languages like Go and C++. When you get into things like Java and the JVM, it's a little bit trickier to kind of get inside that using EBPF, and that's something the Pixie team is working on improving and kind of expanding the use of that flame graph.
Yeah, so non-Go apps are totally observable with eBPF instrumentation, but yeah, so stuff running in the JVM, it's going to show you, hey, this process, and we're probably going to get attributes off of it right from the HTTP layer. So we should have like, hey, it was going to this URL, right? But we may not have, the ability to be like, hey, you wrote this method, right? It's got this method name. That's probably not guaranteed.
Yeah, and so HTTP, if your app is doing communication over that protocol, then you're fine. You'll be able to see, the request headers and bodies and things that I've shown already. If you use HTTP2 or gRPC, that's supported in Golang today, and then the Pixie team is working on expanding that to other languages in the future as well. So,
love it.
If you're curious what is and is not supported, Pixie has a great supported protocols section of their docs that calls out those items I just listed, but things like support for MySQL and Postgres and Redis and Cassandra. So I will try to get into some of the database stuff here in just a bit as well, if you all are interested.
Yeah. Let's see it.
Before I do that, let me show some of the networky things. So like DNS flow graph. In Kubernetes, DNS can get pretty complex very quickly. And so you can see, which services are making calls to kubedns and, potentially which ones are slow. So it can be tough to figure out what's slow and where without some sort of visualization like this that's looking at, how many requests are being made, where are they coming from, where are they going to? And so Pixie does a great job of providing certain visualizations specific to DNS. DNS query summary is another one. So I can scope this to a specific namespace, scope it to my sock shop again. And now I can see, all the different things that are making DNS requests in that namespace. And, we've got all the raw data down here. So you can see, all the different specific requests being made and, quantities and unresolved counts and things like that. Super helpful. And then things like NetFlow. Show me which services are communicating with one another. And then, show me how much data is being transferred between those services. So it just kind of depends on what you're trying to troubleshoot, what area of the cluster you're looking at, and what type of data you're interested in. But it's all driven by the Pixie scripts. And so there's different scripts for different types of data. I mentioned HTTP data. This is an example of a script that shows you all the HTTP calls happening throughout the cluster. So this is also useful for those troubleshooting scenarios, which I can actually show you now if we want to transition a bit. Yeah. I can generate some errors. I can show you where those errors might live using a custom pixel script And then I can get down into the actual database query that we discover is causing some of those issues.
Oh, I love it.
So let me clear out my terminal here real quick. And then I'm going to trigger some more errors so we have some recent data to work with. And we'll go ahead and start this from the cluster script again. I'll go into my sock shop namespace. I'll drill into the catalog service. And then I'll show you a cool feature that's kind of hidden right now. I think we're going to highlight this a little bit better. But you have the ability to edit these scripts. So I hit Command E. That's the pro tip for the day. Command E in the new Relic UI will open the pixel script editor. So regardless of what script you're looking at, you could come in here and you could update this script. Maybe you want to filter out, you're looking at the HTTP data script and you just want to see anything that's has a response code 400 or greater. You could do things like that. You could also have your own little library of pixel scripts that you use in your day-to-day job to troubleshoot issues that are happening in the cluster. So if I run this HTTP data demo script that I've written, it should pull back, sure enough, some of those errors that I caused on the front end. So let me format this a little bit better. And now we can see what's going on. So, okay, so let me cat out this script real quick. We can kind of talk through it. So Pixie has tables where it writes all of the data that it's collecting. And so here I'm basically loading that data into a data frame. And then we're adding some metadata from the cluster. So we're adding the namespace context, the node context, the pod context to all of the calls that Pixie is able to see. And then we're associating it with the service name, and we're scoping this to just that catalog service, right? So I know that something's wrong with the catalog. I'm trying to figure out, sift through all the calls that are happening. And I do that, by kind of building a custom script here. And then sure enough, I want to see anything that has a response status of greater than 400. So that's what I've done here. And when I run it, I make a call out to Pixie and it says, okay, here's everything I found. And now I can see exactly what I was requesting. So there's the filters that I've applied. I see a 500 status, internal server error, database connection error. Awesome. I've already found a clue as to what's going on. So there's a database issue. So I have another script called MySQL demo. And in this script, I'm looking at the MySQL events table. So Pixie's also looking at SQL queries happening in the cluster. And so I want to make sure I attach the pod name to these queries so that I can understand where they're coming from and going to. And then I want to see anything that has a response status of 3. But this could be any response status that you might be interested in looking for. So I'll go ahead and run this MySQL demo script. Let me format that. And here we see the pod. So here's my catalog pod. Here's the query that we were attempting to run. And in the response body, here's the query error that came back, or it's a syntax error. And there's an extra R in the OR operator. So I've found the root cause of the catalog UI not returning any images when I apply my filters. It's because we've got a bad character in my SQL query when querying the database. So that's just kind of a quick primer on the power of the pixel scripting and pulling data from Pixie. There's a lot you can do with that. You can do it via command line. You also have the ability to edit these scripts live in the UI and look at data in that way as well.
Yeah, I like of course, any ability to go in and just query from the CLI when you sort of think that you have something which, call it anecdotal or call it event-based, or say like, hey, I believe that there is a specific error message or type of error that is the thing that we're pointing at. So that ability to kind of dive in is really key, right? We need a visual indicator because it is our visual minds that can spot trends and spot spikes and correlations. But this is so important for knowing, like, what is the actual source of the problem.
Yeah, I think Pixie does a great job of providing kind of those boilerplate scripts that allow you to look at known things in the cluster, namespaces, pod, services. But you as a developer are going to have very specific things that you're looking for that, you know more about your services and whatnot than, say we do. So you can customize these scripts to give you the information that you need based upon your own knowledge of your environment and your services.
So yeah, I saw that there's so many pixel scripts. Well, I don't want to say so many. There's a lot of pixel scripts. Do you have any like top like 3 to 5 like scripts that people should try out that really showcase the power of Pixie?
I think we've hit on my favorites anyway. So cluster, the DNS scripts are really interesting. HTTP data, obviously. Filtered is kind of a cool one. So I can type in a service name. So maybe I want to look at, say, the cart service. Well, nothing recent. How about we try a catalog then? So you can start to kind of scope this to specific pod names or request paths and filter through data that way. So there's different, versions of this available. And then you get into things like, largest HTTP request. That could be useful to someone, especially if you've got a ton of data being transferred where, in the past, maybe you didn't. So you're trying to understand, okay, what in the world is going on? It looks like we've got some giant image maybe that is causing some issues. And so this looks like a script that someone provided from the community and Pixie thought it was useful. So they put it in their repo. Speaking of repo, we can go out to their
transition. Can we just have a shout out for that amazing transition?
Yeah, I love that.
It's like I've done this a few times or something. So in Pixie's GitHub, they have under source, you can see pixelscripts. So here's a list of all those same scripts and a little bit more about them. You can get in and look at the source. You could submit a PR if you want to add your own scripts to their repo. I'm sure they would welcome that, but this is where all that lives and kind of where it's sourced from.
Yeah, I really love having an example repository for people to try from. Okay, so we started at the high level. We saw cluster connections. We saw rates of communication. We saw a nice service map. And then we dived all the way into looking at like individual error reports and being able to correlate those and find what we think might be offending methods or the source of trouble. What else do we need to see?
I think we've covered a lot of it. Actually, we can maybe finish on this. So I've showed a lot of Pixie and what we've brought into our UI from a Pixie perspective. But we've also got, the New Relic integration. So I can drive from this service over to the service details. And so if you use New Relic APM today, this view should be very familiar to you. So notice that I'm now looking at a services category called OpenTelemetry. This is where some of the Pixie data lives, as well as other OpenTelemetry related services. I'm looking at the catalog service. And here's the response time, the throughput, and the error rate that we have shipped from Pixie to New Relic using our integration. So you can see the errors that I generated here. We also bring in the relationship. So if you think about that service graph that lives on the cluster in Pixie, New Relic's borrowing some of that information so that now we can say, okay, I'm looking at the catalog service. It runs, or it's being called by the front end. It lives in this cluster and it's hosted by this pod. So if I'm in New Relic, now I have, I'm able to orient myself very quickly as to where this is, where it's running. And, that gives me a lot of valuable information up front.
I really like
service map.
Go on.
Service map, similar to service graph, just kind of New Relic-ized. So we're able to see those entities that live in the New Relic platform and how they're connected and, how they communicate with one another. And then if you have alerts built, so now that this data lives in New Relic, I can build alerts so that when something goes wrong, you can be alerted off of that specific entity or metric. That's one thing that Pixie doesn't have in its UI and its platform is the ability to alert on things when things become abnormal. So New Relic's going to provide some additional value there.
Yeah, this is the whole thing with, Pixie being able to emit signals to New Relic, right? Is that we can do both alerting and also anomaly detection on those signals. So saying things like, hey, no, we're not out of memory. We're not just alerting you on a straightforward failure, but saying, hey, we see that there is some anomaly here. Throughputs, doubling, tripling every few hours. Like, let's notify you of that, even if it doesn't really pass an alert threshold.
Yeah, exactly. And just kind of drilling through some more of this data. So we're looking at the transactions coming from this service, and I've grouped them by the status code. So you can actually see those 500s that I generated right here. And, I'm able to quickly see that in our UI in addition to Pixie's UI. So it just kind of, depends on what you're looking to do with the data. You've got the live data on the cluster in Pixie, and then you're able to alert off of it in New Relic. Quick plug for some of the other solutions that we have or in the platform. So for example, because we are synthesizing entities in New Relic, I can go to services, open telemetry, scope this to my demo account. And so now I can see, kind of the golden metrics that we're bringing into the platform. If I set up some alerts, I would see those here. And then we have our anomaly detector, which is what this is. And since it's a demo scenario where we don't have anything abnormal happening, but we would then be able to analyze these signals over time and help you understand when things become anomalous, which is what this lookout view provides.
Yep. I really, really like that. And, if you're watching and you have not tried any of the New Relic anomaly detection stuff, do check it out, because the ability to quickly see that, when we talk about mean time to innocence, or what sort of thing we might be what area we might suspect, or we know something's wrong, we really don't know what it is, and we want to quickly kind of zoom in. This stuff is so powerful for that, and I guarantee a little time spent, not even setting it up, because a lot of it could just be done with your existing data, but just getting yourself familiar with it and setting up a few channels to receive those notifications will save you so much headache in the long term, and I absolutely love that. All right, I think that's a good note. Go take a look at anomalies. I think that's our launch pad. But Brad, right. you got stuff to plug. You got a SoundCloud album coming out. You got other good stuff you want to show us?
Man, I wish I had a SoundCloud album. I've been out of the music game for a while, but no, I mean, I'm not a big social media guy or anything. So yeah, not much to plug other than go check out Pixie. If you're a New Relic customer, thanks for being a customer. If you're not a New Relic customer, come check us out. Check out Pixie. We've got a lot of good stuff on our platform.
Yeah, I love it. On my side, go and follow serverless_mom on Twitter. If you followed serverless mom on Twitter, well, maybe check me out again. I lost serverless mom. Serverless mom is no more. Serverless_mom forever. I did it in solidarity with the new _relic Twitch channel. That's what happened, and not that I lost a bunch of personal data. Daniel, what else do we need to plug? Come watch the Nerd Lock every Thursday. What else do we need to say?
Well, Nika is going to come to San Francisco to visit me, and that's the only reason she's coming.
That's what
So look out for a SoundCloud album that we're going to record while we're here.
On the topic of obscure bubble tea flavors.
No, it's going to be about observability. Because we're going to do it at the New Relic office. Because I saw on the YouTube channel, on the New Relic YouTube channel, there are rap videos called Nerd Life. Have you guys seen this?
Yeah, no, I was here for some.
I haven't.
So Brad,
I need to go see it.
Marketing at the time to stop, but yeah, sure.
So we might do a part 2 that's slightly less rap heavy.
I'm sorry, I can only represent my own culture, so all I will do is sort of needily sung ukulele tunes to dissonant harp music or something like that. But I have to represent my own culture, which is effete white Northwesterners living in the woods and writing songs about their chicken coops.
That sounds scary on its own right.
On that exact note, it's time to close up the show. Really. Check out us, of course, on Twitch at new_relic. Follow us on Twitter at New Relic. Follow me at serverless_mom. Follow Daniel at Learn W Daniel. And yeah, we'll come back with new stuff next Thursday. We also got some fun little stuff in the hopper as far as like cool stuff, cool little video projects and stuff. So hopefully we're going to get to show that to you in the next month. All right. Thanks for coming out, everybody. Producer Mia, you have done amazingly. And they're going to drop our BRB, I think, in just a minute here.